Welcome. It's great to have you all here with us. You know, it seems like the amazing team at Acellus, every week they're coming out with a new course, a new version of a course, and it's pretty hard to keep up with all these new courses. One that some people are saying they'd like to see is a magic course, which I think would be really cool. But I'm a little bit worried, though, that kids wouldn't be able to get through it. Do you know why? The exams would probably have trick questions, so that would make it a little hard. Okay, a little bit of science news. So scientists at University of Texas at Austin have developed a promising new cancer treatment. Cancer is still the number 2 biggest killer worldwide, and so it's a big problem. With a lot of the cancer treatments out there, they attack the cancer cells, but they also damage good cells. And so these researchers have been working on a way to be able to kill just the cancer cells. And they've come up with a process that they're working on reducing the cost with using LEDs. What they do is they use LED light and ultra-thin flakes of tin that adhere to those cancer cells. And then you can think of it like zapping those cancer cells, but they're able to do it so that they just get the cancer cells instead of killing the healthy cells. And so if they're able to perfect this technology, it could help a lot of people to be able to have a better treatment sometime very soon. So that's exciting. Well, it's time to get it over to Dr. Joshua for How to Study with Acellus Gold.
I'm excited to share that we recently held Acellus AdCon here in Kansas City. If you're not familiar, AdCon is our annual conference that we hold for school district superintendents. And so we had school districts fly in from all over the United States here to Kansas City. And at this event, we share the latest updates and news about Acellus, but it's also an opportunity for schools to present on their implementation of the Acellus learning system and a chance for us to listen and hear the great ideas and feedback that schools have. And I want to share just a few of the highlights from the presenters this year.
We've been using Acellus Gold for about almost 2 years now, and it's been a game changer. We like to compare it apples to apples. So at this time with our previous program, we looked at the first progress report to say, okay, how were our students performing? Were they passing classes at this time? Back then, we had about a 76% passing rate where they had a C- or above. And this year we have 95% through Acellus.
Some of our kids came in at 6th grade and they were at a 2nd grade level. We've moved the needle for them so much that they're now almost on grade level. 6th grade, 7th grade content. They're actually showing 20% growth in their pre and post after vector.
If you are just getting into the Acellus mode, the only limit is your thinking, not what Acellus can do.
Since we've got Acellus Gold, 3 students that have been incarcerated have reached the credit limit to get a diploma.
One of the big things we wanted to make sure when students were achieving a high school diploma from us that we felt like we could stand behind it, and with Acellus we do. We feel that it has the rigor that we were looking for.
I think Acellus will be in our district for a while. I really do, because of the great things that it's doing.
So whether you're studying at home or from your local school, remember to study hard. Thank you.
Well, it's time to get it over to Dr. John for the Technology Spotlight.
Have you noticed that computers keep getting faster and faster and more powerful? Well, they're also getting hotter and hotter. And what's happening is inside of the computer chip, they have all these little transistors, they're little electronic switches, and they're turning on and off. And the smaller they make them, the faster they can run them. The closer together they put them, the more they can do. But they're running into a limit where they're having problems with heat. Remember how when you run electronics through wires, electricity through the wires like that, it actually will put off a little bit of heat. And so if you look at this picture, this is a CPU, this like the brain of the computer. And that little black part in the middle is where the actual computer chip is, the actual brains. And the rest of it is mostly for cooling. And then when they put this inside the computer, they put a giant heat sink on, and they run fans on it, trying to cool it down. Remember, inside of this chip is a little teeny wafer that does all the work. When they make these wafers, they start in a big disc, kind of like this. You can see it's zoomed way in. And each one of those sections is like a little city. You can see all the different pieces. There's the part that does the actual CPU processing. Then there's coprocessors, and there's memory storage, and there's I/O for data going in and out. And they take these little pieces, and they cut them up. And then they take just one of those chips and stick it inside of a case like this. This is zoomed in, and you can see all the little teeny wires connecting the wafer to the chip. And then they try to pull the heat out from the bottom and from the top. And this is how we've been doing these computer chips. But like I say, the heat's been getting worse and worse and worse as they try to make them smaller and more powerful. And it's gotten so bad that we really need a new cool way to cool things down. And there's some work that Stanford University has been working on to use diamond. Now that's a cool way, isn't it? And you wouldn't think that diamond would be the right thing, but it turns out that diamond, the same thing we have in jewelry, like the beautiful diamond ring, well, that diamond conducts heat very, very well, even better than metals like copper, extremely well, but it's also an electrical insulator. And that makes it so it won't short circuit. So the trick is getting the diamond close enough to the circuit to pull the heat out. Here's an image of a diamond that they grew. And this is a little bit different than the kind of diamonds that you would have in a diamond ring. These are polycrystalline diamonds. And it grows kind of like a film. And they came up with a process where they can grow the diamonds without overheating the chip. So they get the chip, and then they grow the diamond on top. And they use ionized gas with some hydrogen and some methane. And so the methane supplies the carbon. Remember, diamond is made out of carbon. And then the hydrogen helps make sure that it forms the right diamond structure. And they found as they lowered the temperature that they started to get a black layer on that was soot stuff. It was a lot like a soot, and it was actually electrically conductive, and it was a problem. And it was going to completely ruin it. But then they realized if they add a little bit of oxygen, that it will continuously react with that carbon and etch away the soot, and so they can keep growing the diamond. So they've been developing this process. Here's another image that shows it really well. You can see on the left the surface before they grew the diamond, and they've got all these holes to be able to conduct the heat out. And then on the right, you can see where the diamond layer is grown on there. And so they were able to test this on some CMOS chips, and they found that they could remove 90% of the heat from where it's hot. Remember, we have these big CPUs with the big fans, but the really hot place is way down in the chip, right where all those transistors are. And it can be many degrees hotter than other parts of the chip because that heat doesn't get conducted away. And so with the diamond, they can pull that heat out a lot better. But, of course, the chip manufacturers make things harder. They have recently especially been stacking the chips. Look at this. Here's inside of one of those chips again, and instead of one layer, they've got several layers. This is actually a memory chip, and so they're trying to pack in as much memory as they can. But when you start doing processing in these layers, the heat is even worse, and it's even harder to get out. So they've been experimenting with having what they call diamond pillars, something like it shows in this diagram. That blue would be made out of diamond, and it would draw the heat from all of the layers out to the top where they can release it. And this is so promising that the researchers have started working with some of the big fabs that make the computer chips, and they spend millions and billions of dollars every year on new technologies, and they make these transistors way down like a few billionths of a meter, little teeny tiny circuits that do amazing things. So now you know another reason diamonds are cool. Yeah, that's all the tech we have the time for.
Now it's time for Breakthrough Moments in Science with Tobias.
You know, technology changes things, right? I mean, like 100 years ago, everybody had a horse, and only the rich people had cars. Now, everybody has a car, and only the rich people have horses. The stables have turned. Anyway, but we're going to talk about technology that has changed the world, namely because somebody had a breakthrough. And, you know, they call Dr. Billings the father of hydrogen technology. We're going to talk about Willis Carrier, the father of air conditioning. If you want to get a title like these two titles I just mentioned, you got to really put it out. You got to learn the subject, you got to delve into it, and then you got to go further than anyone's ever gone and be the specialist. So Willis Carrier. Now, with air conditioning, that's something we kind of take for granted, where when we have it, we forget about it. But when we don't have it, we remember because it gets so hot and muggy, right? Well, Willis, we start this story right after he got out of college in 1901, and his first real job was as an engineer. There was a company that was a printing press, and they not only had a printing press where they could print like magazines, newspapers, and stuff, they were high tech because they could do color printing. And this is printing, you know, in 1902, 1903. So when I say printing colors, that meant if you had a paper, you were going to print a picture with color like that magazine cover, it would go through and get 4 different colors on top of each other. Okay? So you get one color, then the next one. But they had a problem, and that is the papers, when they'd go back through, wouldn't align perfect. And so the different colors would not align, and you'd kind of get these ghosting images and not perfect edges. And when they looked into it, they realized the humidity and temperature in the factory would change and would actually make the papers warp just a little bit, but enough to make the papers, the prints, look wrong. So Willis's assignment from his company was, you need to figure out a way to make this factory's air in the factory building constant in temperature, but also in humidity. And so he talked to the guys there, and they decided that we need it to be this certain temperature, and we need it to be 55% humidity. So that's his goal. Now, they already had ways to cool a room. You know, they had things like you could do ice boxes and blow air through the ice, and it would cool the room. But not just cooling, and that's not a very efficient way, but also how do you control the humidity? He couldn't just put dry air in, because if it got too dry, that would be a problem too. They needed 55% humidity. So Willis is thinking about this, and one of the things people who knew Willis said was when Willis had a problem he was trying to solve, his brain would just fixate on it. There's a story that one time he went on a business trip, and when he got there, he opened his suitcase and realized he had just packed a handkerchief. He probably could have written a book, 101 Clever Ways to Use a Handkerchief. But he would fixate on it, and that's exactly what he did. And he said his aha moment when something just clicked in his brain was he was sitting at a train station at night thinking, waiting for the train, and he noticed it was getting foggy. Okay, have you ever noticed the fog coming in the cold night? Well, he noticed the fog, and he said, all of a sudden, I realized what I needed. Because one of his problems was, how do I set the humidity when I don't know what the humidity's at, and then I don't know, how do I know what the humidity is of the air I'm putting in and what the air is before? So he needs like a starting point of how he's going to control the humidity. Well, he sees this fog and he realizes, I know how to do it. Now, to think about humidity and air, a really nice way to think of it is the relative humidity, as they say. So relative humidity, it turns out, so humidity is how much water's in the air, right? In that gas form. It's not actual water droplets, it's in a gas form. And the relative humidity is how much humidity in the temperature of that air. Because if air is warmer, it can hold more humidity. If it's colder, it can't hold as much. So if you have this air and this humidity in the air, it might be 60% relative humidity. But if this temperature changes, so does that number. So a really nice way to think of this is if you think of the air outside, it's a summer day, and there's whatever humidity. Let's say there's 60% humidity. It warms up. What happens when it warms up? It starts going up because hot air rises. So it starts going up, and that 60% is now going into air. The air is cooling. So as the air cools, the relative humidity, it's the same amount of humidity, but the relative humidity changes to 70%. It gets higher, colder, 80%, 90%, 100%. When it hits 100%, guess what happens? Clouds. So when you see clouds forming, it's the air getting cold enough that the humidity, it can't hold anymore, and it turns back into water droplets. And so if you think of fog, that's exactly the same thing happening near the ground, where the temperature cools enough that the air can't hold the humidity, and it gives it up as fog. So when he sees that fog, he realizes what he's going to do. So he's going to make a box. He starts with this contraption. He has a fan. He's going to blow the air into this box from the factory, and it's hot, it's humid, muggy. He blows it in, and then as it's coming in, he uses this garden spray hose nozzle that makes this really fine mist. Well, the mist, he sprays cold water into this hot, humid air. What happens? The temperature drops of the air, and it can't hold that much water. And so it starts giving up some of the water, and it creates fog in this box. He's able to make fog inside of his box. When he does that, what's the percent, the relative humidity percent of the air? Whatever it was, it's now 100%. Because if it's giving up fog, it's at full saturation. So what he's done is he figured out a way to get 100%. Now he knows he has 100% humidity. He can tweak and adjust it. So let's say he wants to get it down to 55%. If he puts in dry air at 45% amount, he can mix it and get his mixture exactly what he wants. So here's his patent that he patented, and he called it the apparatus for treating air. And he patented it in 1906, and you can see kind of some of his drawing there with the spray. But he created 100% humidity, and then he mixed it to a controlled amount. And this factory, with his special machine, would be the first air-conditioned building where not only the temperature he was able to keep consistent, but the humidity he was able to keep consistent, air-conditioned. And eventually he would add these coils for evaporation, and that we're not going to get too deep into, but when they added that, they were able to cool it even more efficiently. And they calculated that the cooling system he put in this building was the effect of melting 108,000 pounds of ice a day to cool that building, how much they needed it cooled. That's a lot of ice saved. And all of a sudden, it transformed factories. And that's kind of where this started, is in factories. And they needed it cooler. So this is just step one, though, because the next thing Willis did is he went into the math and the science. And he actually, a couple years later, he released in 1911 a document that basically took all of this information and more and based it on science and math, like deep math. And the formula and formulas that he put together are still used today for the foundational principles of air conditioning. And he took it all down to the actual math and how you can calculate these things. Well, after factories started getting everywhere, there was a store in Detroit that worked with Willis. And people would actually go to the store just to be cool, not that kind of cool. They were hot, so they went in the store, and it was nice and air conditioned. And maybe we'll do some shopping while we're here too. It worked nice. The next place, movie theaters. Because if you think about it, basically, when it's summertime, movie theaters was not a place to go because you go sit with all these people in a hot room. All of a sudden, you could go to movie theaters anytime because air conditioning. And then finally, in 1928, so eventually, he makes one for the home, and he calls it the Weather Maker. And you could actually have air-conditioned air in your house. And again, it's something that's so easy to take for granted when you have it. But this would transform so many industries and, of course, so many homes and cars and even save lives. And all from this need, and then someone took that, figured out a solution, but then drove it into the science, the math, and really made a science of it. So work hard, study hard, do your math, do your science, and maybe you'll invent something that is cool. Thank you.
Well, it's time for me to introduce the father of hydrogen technology, Dr. Roger Billings. You know, he didn't just invent hydrogen cars or convert cars to hydrogen. He converted a home and even the tractor. And while he was living at the hydrogen homestead, he has a visit from a reporter at Mother Earth News. And this is what they said. Between manufacturing computer systems and doing hydrogen research, Mr. Billings is quite a busy gentleman. Nevertheless, he took time to discuss the various aspects of hydrogen power with us, including its production and use as a fuel. The points he brought up were interesting enough, but the equipment he demonstrated was even more impressive. It provided us with proof that hydrogen power isn't just yesterday's dream, but today's reality. Please welcome Dr. Roger Billings.
Very busy man.
Very busy.
Still.
Mm-hmm.
Still.
Still. I don't still.
That's good.
You shouldn't accuse me in public.
That's wonderful.
Well, we're having a lot of fun today, aren't we?
A lot.
So, air conditioning.
That's really nice, isn't it?
Inventioneers are people that solve problems. Someone very wisely once said that a problem is the mother of an invention. So if you want to invent something, start by looking for problems to solve. Mm-hmm. Boy, that was loud.
That's awesome.
I need to invent a way to mute my mic when I have to cough.
Why? I think everybody's awake now. What do you think?
Do I have your attention? Okay, good. While you're awake, if you can find a problem, you're halfway to making an invention. Mr. Carrier found a problem. Air conditioning was needed. People were uncomfortable, and so he made a way to cool down the buildings. When I was at scout camp as a young lad, we went out there and they had a place, they called it an outhouse. And that was actually...
It's a nice name for it.
That was a nice name for something that wasn't so nice. And you know, you could tell when you were getting near the outhouse because you could smell it, you know, the outhouse. And you go in there and, oh boy, it doesn't have a flusher, just a hole. Anyway. And so I came out one day kind of complaining about, you know, the outhouse. I was used to a nice modern bathroom with a little lever, everything goes away. Mm-hmm. No smell, no nothing. I just said, oh, this is. They said, you should have been here before someone invented the outhouse?
Yeah.
And I started thinking about it out behind the tree. What about before someone invented toilet paper? And you see, they invented it because they realized there was a problem. A problem is the mother of invention. Now, I got involved in an air conditioning project too. Did I ever tell you about that?
You didn't.
Well, Bill Lear was my mentor. And Bill picked me up in his airplane and took me back to live with him and to work with him and to be mentored. And as soon as we got there, the very first project he gave me was fixing the air conditioning in his Learjet.
How did he give it to you?
Well, let me just show you. This is a
okay.
picture of a Learjet. See, there it is. These are amazing jets that were invented by Bill Lear so that executives could fly high and fast over the weather and get where they needed to be when they needed to be there. But when a Learjet was sitting on the tarmac, they call it, while we were loading, unloading passengers, waiting for people to come, they would get very hot. It was like a car sitting there, and light would come in through the windows and it'd get really warm. They had air conditioning, but to turn on the air conditioning, you had to start one of the jet engines. And those jet engines burned so much fuel just sitting there idling that you'd empty the fuel tank before you ever took off. And so Bill Lear wanted a way to keep his jet cool while it was sitting there stationary waiting to take off. And so he came to me and he said, Roger, I've got something to show you. And he took me in his little shop there, and he had a round engine. It was a Wankel engine, meaning a rotary engine. And he said, I want to use this 5 horsepower motor to power my air conditioning system when we're stationary on the ground. He said, why don't you just start the big jet engine? He says, because it sucks fuel.
Yeah, it
Okay,
does.
so make this engine run. Well, the engine already ran, on gasoline. He says, we don't want to put gasoline on the airplane. We'd have to get certifications and everything. You need to make it run on jet fuel. Well, jet fuel is a fancy name for diesel. Jet A is just diesel fuel, only it's really nicely filtered and made sure that there's no water in it or something. So how do you make a gasoline engine run on diesel? And I didn't know if that was even going to be possible. But he had a problem. He wanted to cool his jet. He needed a small engine. This is a very light little engine, but he needed to run it on jet fuel. Okay, now you're becoming hysterical.
Well,
Could we cut off her part of the screen?
I just realized people say, you cool your jets.
Cool
when you're
your
a little
jets.
bit,
That was the whole idea. He wanted to cool his jets. Okay.
You're a little bit
Yeah, try
fiery.
and keep your mind on the subject, okay? I realize that's hard. It's like this.
It is.
Anyway, so I figured that jet fuel, in a diesel engine, they actually compress air with the piston. The piston comes up and compresses the air. A gasoline engine compresses it about that much, maybe about 8.5 to 1. That means it's 1/8 of the volume as it was when the air came in at atmospheric pressure. But a diesel goes twice as compressed. It'll go up to like 16 to 1, 18 to 1. And when you compress air that much, it gets so hot that if you squirt fuel into it, it automatically ignites. So a diesel engine doesn't have a spark plug. Did you know that?
I did know that.
Okay, you did. But maybe they didn't. Okay, did you know that? Yeah. No spark plug in a diesel engine. So they compress the air, it gets really hot, and then at the right time, they squirt in just the right amount of diesel for the power they want. If they just want to idle the engine, they squirt a little bit. If they're trying to go up a big hill fast, they squirt a lot.
Okay.
That's all. But gasoline engines, on the other hand, they pull the fuel in with the air, they compress it a little bit, and they light it with a spark. How am I supposed to make a Wankel engine in German, how do you make that run on gasoline? So as I started thinking about it, I had a problem. That was actually his problem, but he gave it to me. That was my first thing. I thought, you know, I don't want to look bad.
No, you don't. I didn't. At all.
I didn't?
Well, you
It's
wouldn't.
gonna be
I
a
wouldn't.
long session.
Make a good
So the
impression.
first thing I realized is that gasoline evaporates easier than jet fuel. Jet fuel, if you ever played with diesel, it's kind of a little bit thicker.
Are you suggesting they put
And
it
so I figured that if I wanted it to vaporize so that I could get it to burn in the engine, I would have to do something. I would have to either heat it up, or that was out of the question. And I came up with this idea that if I had a real small carburetor, and you remember a carburetor is a thing that mixes air and fuel before it goes in an engine. If I had a real small one, the air would have to go through at a high velocity, and that would vaporize this jet fuel. And so here's a 5 horsepower engine, and I remembered the little Briggs & Stratton lawnmower engine that I had used in the science fair not many years before that, and it was only 1.5 horsepower. So I thought, if I could get a Briggs & Stratton carburetor and make an adapter to hook it on the winkle, maybe it would run. Probably wouldn't run real good, but he didn't care if it ran real good. When I say real good, absolutely no pollution. He just wanted it to run for just a few minutes. So we did it, and it worked.
Wow.
Problem solved. Kind of interesting. Another problem that Bill Lear ran into is that when you're flying an airplane, you have to hold it on course to where you're going. You have to keep it at the right altitude. You float up, float down, and you're trying to do a lot of other things. And he thought, wouldn't it be great if you could just turn on an autopilot, and then the airplane would maintain the altitude and the course. And so he decided he was going to invent an autopilot to help pilots fly these airplanes, give them a little break. So he started working on it, and he had this first little gadget that he put in his little airplane, and he took it up for a flight to test it. And this is a true story. I remember him telling me this, and I wondered for years now if I dare tell you. But now that you're mature,
Oh, there you go.
I think she can handle it.
Are you talking about now that I'm mature?
Yes, ma'am.
Barely.
So anyway, this is the way the story went. He had his little airplane. It was a 4-seater, and he climbed in, and he took Bill Jr. with him on this flight, the way he told me the story. Bill Jr. was sitting in the passenger seat, and Bill Lear Sr. was in the pilot seat, and he had this autopilot. Well, they started flying, and he was trying to get it to work, and it wasn't working right. And so he got down on his knees and was working on this autopilot, trying to get it to work. And little, I guess 3 or 4-year-old Bill Jr. was looking around all by himself, and the airplane drifted off course and went over the military base.
Oh, dear.
Now, you're not supposed to fly there.
Oh, dear.
That's protected airspace, and he's working, and a fighter plane came up to find out what's going on. You can't be here. And as he lifted his head up, he saw the fighter. Oh, shoot. Oh, shoot. So he ducked back down. And so he told little Bill, wave at him.
Oh, my goodness.
So
Oh,
here's
my
this little
goodness.
4-year-old kid flying the airplane. And that's a true story. But he had a problem, and he eventually did, in fact, make that autopilot. And boy, it changed aviation.
It did.
And I was so excited to get to go on a flight in an airplane with the guy that invented the autopilot.
Yeah.
But I didn't realize what a thrill that was going to be. That day he picked me up to take me back to live in his home. I got in the plane, and this little Learjet has a little walkway that you go back to get into the seats. And up and down that walkway were all these boxes of electronics with wires going between them. Maybe we should build the airplane before we take off. And he said, oh no, this is the new generation of autopilot I'm working on. Really? Oh, now I'm part of technology. So we got in the airplane, we took off, and he's there, I'm on the jump seat, which means I'm looking backwards. I'm going to look around the corner at him because I was trying to see. And I said, so how does the autopilot work? And he says, well, watch this. And so he started doing, He got out of his seat and he went back to the box on the floor in the back, and he pulled out a screwdriver and he started turning something. And the plane went, okay, never mind.
He was
That's how I
quite the
learned about the
gentleman, wasn't
autopilot.
he?
He was a lot of fun.
something else.
It was a lot of fun. Learned a lot of things
Was he
from
funny?
him. Bill Lear was very, very sober. And if you listen careful, he would crack you up. He just say it kind of under his breath, and it could be
So
hilarious.
he's very clever.
He was a very, very, very clever guy.
You're clever.
And could you say that so they could all hear it?
Dr. Billings is very clever, and he says things under his breath. I bet you learned that from him.
Clever,
He
huh?
didn't deny it. So.
Okay, so let's keep moving forward here.
I'm moving
okay,
forward.
so
Let's
we're
go.
moving forward. So today we want to talk about problems, and you can think he just keeps talking about problems.
You do.
Yeah, and here's why. A problem is the mother of an invention. If you can identify a problem that needs to be solved, then all you got to do is figure out how to solve it, and you have an invention. Okay? For example, what if you have mice, a lot of mice, and so you set a mouse trap, and then another one. What if you could invent a mouse trap that would just keep catching the mice and you wouldn't have to come reset? A better mouse trap. That's a famous thing people talk about. Invent a better mouse trap and the world will beat a path to your door. Well, if you can do a better job, great. How about a better fly swatter?
That'd be
If there's
good.
a problem getting, all you have to do is identify a problem that you're interested in, and then figure out a way to solve it, and you do something really marvelous. Now, there was something that happened with Bill Lear that was really life-changing for me, and I'd like to kind of share it with you because this is one of the major projects I'm spending time on right now. When I went to work with Mr. Lear, his project was he was going to overcome the pollution problem and the oil embargo problem that we were facing as a nation, and he was going to do it by making a vehicle that would run on steam. And specifically, he was working on a steam bus, a bus that would burn jet fuel,
Okay.
of course, and would have no pollution and would save a lot of fuel. Well, my second project with Mr. Lear was to fix the combustor. The combustor is where you put the jet fuel, you burn it to make heat, the heat makes the steam, and when it came out of the exhaust pipe, it had a lot of pollution. He said, Roger, you need to make it burn so there's no pollution. That was my project, and so I started working on it. But we had another problem. One day we took the new steam bus out for a test drive, and they were measuring how much fuel it was consuming. They did the calculations. They came into his office. We got the fuel consumption results. He said, oh, good. How well did we do? And he said, 2. 2? You mean 2 miles per gallon? That's terrible. And I said, no. I mean 2 gallons per mile. It was really consuming a lot of fuel. It was a problem. And getting it to burn free was a problem. When you can find a problem, you're halfway to an invention. I'd like to challenge you to think about a problem you would like to solve. If you had been born a little bit earlier, you could have solved the problem of inventing toilet paper.
Yeah.
A little late for that one. So what are you going to invent? And any problem that you can see, and it could be because something doesn't work, or it could be because you think it could work better, whatever it is, that is going to be your invention. This next year, next spring, we're going to have the science fair, but we're also going to have this new thing called the Invention Fair. And if you can invent something and submit it in the Invention Fair and win a prize, you're going to have not only a nice prize to put on the wall and on your resume, but we are also going to fund the best ideas to turn them into commercial projects.
Wow.
So
That's exciting.
I really, really, really want to motivate you to be inventioneers, okay? So let's go on. Now we're talking about that bus, and we needed to get much, much better mileage. So when Bill Lear found out that his bus was burning 2 gallons of gasoline every mile, which is terrible, by the way. Normal bus should maybe be 10 miles per gallon, not a half a mile per gallon. So he turned to me and he said, Roger, do you know of anybody that's got a positive displacement machine? I'd been to school, I'd majored in 5 fields. I'd never heard of a positive displacement machine. I had no idea what that was. And I thought, and I said, no. Well, if you hear about one, let me know. He thought that if we could find a positive displacement machine, we could really improve the efficiency. And what I learned later on was that a positive displacement machine would be like a gasoline engine, where you compress it and then you light the spark and it expands, but it's in a contained container, and so it's much more efficient. I want to show you a little video of a jet engine. This is how jet engines work inside all of our jet airplanes. So you see the air goes in, it's compressed by all those different layers of compressors, then they burn fuel in the middle, and then the hot exhaust goes out the back, and as it goes through those back fans, it puts the power there to turn the front compressors, they're called. That is a jet engine. Jet engines are very, very popular. They're all over the world, and the reason that they are is because a small engine can generate a tremendous amount of power. A little lightweight engine, you say, I saw a big airline, it wasn't little. Compared to how much power it was producing, they're very little. And they can produce an enormous amount of power. But there are 2 problems with jet turbines, jet engines. Number 1 is they waste fuel. They're not a positive displacement machine. They waste fuel. So that means that fuel, which is very expensive, is even more expensive because you don't use it very efficiently. The second problem is jet engines are terribly expensive. Terribly expensive. If you get a rebuilt engine for a little private jet, you're talking $2 million for a rebuilt engine, not a new one, a rebuilt one. And like my little Falcon 50 has 3 engines, so that's $6 million for 3 engines. Mm-hmm. And you have to keep remodeling those or rebuilding them after just a few thousand hours of flying. If someone could invent an engine that was really lightweight for the amount of power it was generated, comparable to a jet, and if they could make it be a positive displacement device, it would change the world. And so after Bill Lear asked me that question, I've been grinding on it and grinding on it and grinding on it. You know, sometimes it's easier to find the problem than it is the solution. Thomas Edison said, I can't see anything out there. What's wrong? And the guy said, it's dark. Oh, that's a problem. Yeah. And so he invented the light bulb. Well, I thought it's time to make the next generation of turbines. And so when Bill Lear was looking for the right thing to run in his steam engine, he called it lyrium. We're going to discover lyrium. And he did a big project to find out what would be the best thing to use to run the steam engine, and end up being steam. So lyrium was steam. Well,
There we go.
So I named my project, I call it the Billings Turbine.
That sounds good.
Yeah, and I have been working on this. I built my first prototype before the year 2000.
Yeah?
That's way back there. Some of you don't even remember that. I don't either, hardly. But we did, and we learned a lot, but we encountered some problems we couldn't solve then. So I've been working on them all this time, and now I'm really, really excited about the Billings turbine, and we're building a new prototype. This was designed originally to be a hydrogen engine, and it's an excellent hydrogen engine, but I'm also making a version to run on jet fuel with the idea that maybe we can put these in jets. If we can, well, then it will be a very, very wonderful, positive thing. In a regular automobile engine, we talked about this last time. We have the piston that goes up and down. It's hooked to the crankshaft, so every time you shoot a spark, it pushes the piston down hard and turns the crank wheel, okay? When you take an object like a piston and you accelerate it, it takes energy to get it going. And then when it gets to the top, it takes energy to stop it. And then it takes energy to get it going the other direction. And not only does that waste energy, starting, stopping, but it also creates a lot of vibrations. And because of the vibrations in the engine, you can't run it very fast. A regular gasoline engine might run between 4,000 and 6,000 rotations per minute, which 4,500 would be more typical for a regular gasoline engine. If you think about it, that means that 4,500 times a minute, you're lighting the spark and giving an explosion and getting that much energy. What if you could run it twice as fast? That means you would burn twice as much fuel, you'd generate twice as much power. So the secret to really make a powerful piston engine would be to change it to much higher RPMs. In fact, what you'd like to do is get up around 20 to 30,000 RPMs. Then you could get enough power out of it to make it light enough to put it in something like an airplane. But in order to be able to have it turn that fast, you can't have a piston going back and forth, beating itself to death and wasting energy, starting, stopping. And so that's where the magic of this design comes. And it's kind of ingenious. I want to show you a picture of a Wankel engine. This is looking inside the engine that I converted for Mr. Lear. Can you see that triangle? It turns around and it compresses gas and expands, but it's just going in a circle. The problems with the Wankel engine are it has a big sill on the top that has to go all the way around there. It wears out. It's hard to lubricate. Wankel engines have to squirt oil in with the gasoline, so they put out a little more smoke. And they've been a lot. The Mazda made the RX-2, which was a Wankel engine, and I had one, and it was fun. But they never really caught on because there's a real problem with that design. There's another rotary engine. I'll just show you a photograph of this. This shows you how wacky they can get. See that one? Wow. Shows little funny gears. So that thing turns and compresses the gas and gets work out. I've got a little video of that. Let's put it in motion. Here we go.
Oh, goodness.
Isn't that crazy?
Yeah.
So that's how that one works. And no, it didn't catch on.
Yeah.
So making an engine that has pure rotary motion, nothing going back and forth, it's just spinning, like a jet turbine just spins. Jet turbines, by the way, can go at very high RPMs. That's why they're so light for the power, one of the reasons. They're also very simple, so they're very reliable. You need to have an engine that's incredibly reliable. And so that's kind of the challenge we have with these engines, and that's what we're working on. Yes, speak. Time out. We have an interruption coming in from the left side here. Your right side, my left. Okay, we're ready.
We have a big request from Lacey from
We have
Virginia.
Lacey, Virginia.
Yeah.
Well, hi, Lacey. How are you doing?
She wants
How's
a shout
Virginia?
out. So she has been watching Science Live for 3 years and more. And she
3 years and more. Now, how's that work?
It says, I've been attending Science Live for over 3 years. So
Okay, good.
My words, 3 years and more. But she's really grateful to you, and she knows her major, and she has learned a lot through these. And so she's
Well,
just saying
bravo
thank you.
for Virginia. It's so nice to hear from you. It's wonderful to get all these comments. I wish we had time to read them all.
I know.
We're going to fix up a thing so you can post them on the Science Life site because
fun.
we're getting a lot of really
Getting a
fun
lot.
comments.
Yeah.
We could just read them all night. It'd be
We
really
like
great.
them a lot.
What else?
Well, I want to know more about your engine.
Oh, good. So I thought she'd never asked. Now here's my chance. So we're now designing the next prototype. We've been doing what engineers call an engineering study. So we figure out the diameter, the shape, the rotations, the compression ratio, and everything. And then we put it in a computer and we model it using engineering, using math, using chemistry and physics to try to optimize it. And there are things about this engine that will make it much more efficient than even a regular internal combustion engine, but more efficient than a jet turbine.
Okay.
And if we can get all this to work just right, it's going to be a big, big deal. We'll be able to use them in hydrogen cars. We think we'll be able to use them as an engine for jets. Because of the simplicity of the design, which is really bizarre, we think we'll even be able to make little drones. You know how you have little electric motors?
Mm-hmm.
The only problem with drones, they can only go 20 or 30 minutes. They have to go charge the batteries. Well, if you could have just a little gas tank there with these little engines, you could have them fly for hours, which would be pretty neat, wouldn't it?
It'd be fabulous. So is it the Billings turbine, the Billings engine, the Billings turbine engine?
Amen.
Amen.
Yeah, we'll see how it comes out.
Oh, okay.
I call it the Billings turbine when I'm talking about the version that we're designing to go on an airplane. And that version has to be very, very, very lightweight. We're more concerned about it being light than being affordable. We'll pay a little more, but it's got to be really light. The Billings engine is the one that we would use, say, in an automobile. It can be a little heavier, but it's got to be affordable. Both should be efficient.
This is exciting.
It is exciting.
Very exciting.
And if it doesn't work, I won't say any more about it.
Okay, so stay tuned.
Just stay
They're going to
tuned.
watch every Wednesday to find out about your engine.
Well, it's just exciting. So rotary engines then, just in summary, is an engine that everything's in pure rotary motion. If you got something reciprocating, that means going back and forth, that's not a rotary engine. In a turbine, can we put that turbine back up again? The jet turbine, if you look at this, see how it's just all symmetrical and it's just spinning around. That is a pure rotary motion engine. And that's what we want to do with this engine. But we don't, when that's spinning around, you have gases that leak around those compressors. The compressors are very hard to manufacture. That's where we think there's a real opportunity to improve the efficiency, lower the cost, and make a big difference. So there's a problem of cost, problem of efficiency. If we can get these things perfected for the same amount of fuel, you'll be able to get on an airplane and fly further. A big cost of flying in a jet is fuel, a real big cost. If we can lower that, it would make a big difference, okay?
It'd make a huge difference.
So a pure rotary engine means, pure rotary motion means nothing reciprocates. It just all just spins around. And if someone can come up with an ingenious way to do that, they just may have a major breakthrough. I am so excited about it now. I hope he's not listening, but I was telling my one and only brother about the progress we're making on it, and he sent me a text this week and said, last night I couldn't even sleep. I just laid awake all night thinking about your engine. Yes.
I think it's exciting
But
too.
you know, it is exciting to invent. So I want you, please, start looking for a problem, any problem, and then solve it, okay? Now, I will tell you a little off-the-record comment. It's real easy to find problems, I usually go through about 100 problems before I find one that I think I can solve. So you got to kind of pick your problem too, but a problem is the mother of invention. You got to have a problem to solve, then you invent a way to solve it, then you're an inventor. In fact, even R51 is getting into inventing now. We've got a minute to tune him in.
Okay.
R51, where are you?
Scratch.
Hello, everybody. Welcome to today's episode of the adventures of R51.
Oh my.
In the land of Area 51. Here we are. Today I'd like to welcome our special guest, Lady Dr. Paget Monet, my favorite teacher, and she's got some of her little alien friends from her planet.
Goodness.
It's so nice to have you guys here today, and we're going to teach you some wonderful things. This little critter, he can't do anything.
Oh my goodness.
He just wants to get going, so he came to Area 51 so that we could give him propulsion. So we're going to invent propulsion so we can put it in this little guy, and boy, he will go. You'll see. Now, let's just take a minute and understand. Here in Area 51, for these recent days, everybody is focused on inventing rotary engines. You see, if you could make a turbine engine, it would be so amazing. And I'm going to explain to you what I mean by rotary engines. See, can you see, this is a piston, and you put this in an engine, and it compresses the gas, and then you light it with a spark. And when you light it, it goes boom, and it pushes the piston down, and that's how you get your car to go. So just think, you got the gas, you compress the gas, and then you ignite the fuel, boom!
Oh my goodness.
And the piston pushes down. But here's the problem. In an engine, the piston goes up, and it goes boom, up, boom, up, boom. Going up and down, it takes a lot of energy to get it going up, and then it has to stop, and it takes a lot of energy to get it going down, then it has to stop. That up and down wastes a lot of energy. So if you could make it just twirl somehow so it wouldn't have to, it would be so much better. And that's why I invented this rotary engine. Look at that. It doesn't have a piston that goes up and down. It just goes around and around and around. Now, to power this rotary engine, you need to have some fuel. And you see, I've got some fuel right here in this fuel tank. And to make it safe, I put it in this little prison. You see? It's a cell. A fuel cell, get it? And if you lock the fuel in with your little padlock like that, then you know it's going to be safe and nobody's going to get hurt. None of these little critters, certainly not. Dr. Lady Paget. So here we go. Now, like I was telling you, this is going to be just, wow, it's going to be crazy. So we have to turn on the gas. Got it? And so the gas is going into the rotary engine, and you have to give it just a little kiss to get it going. Just a little kiss. Boom, 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 boom. See, it's starting to generate power, and it's going back and forth and back and forth. Can you see that, Lady Paget? It's generating power. Now watch what happens when I take the little funny critter over here and I hook him up to this so that we generate lots of power for him. Now watch what happens. Oh, it's happening. Whoa, it's happening. Look at this. Oh, it's so exciting. He's getting the energy from this hill. Oh, he almost fell. Thank goodness I was here to catch him, because otherwise he would have fallen right off here, wouldn't you, little critter? Look at it. So, does anybody have any questions? Oh, he did fall. That's so sad.
Oh. Oh. Oh boy.
Well, that's all the time we have this week, but we'll see you next time where we're going to do more inventing. We're going to slay more problems and make the world a better place for everyone. Thank you. We'll see you.
Bye.